The Covert Origins of Modern Cyber Operations, a NEXION documentary. What happens when fragile networks, once built for connection and research, become instruments of statecraft and strategy? In the modern era, digital incidents can reshape economies, test institutions, and force new rules of global conduct, all without a single uniform on the ground. This is a story of how early curiosity and covert reconnaissance evolved into the organized cyber activity we must understand today. Welcome to the Covert Origins of Modern Cyber Operations. Chapter 1. From Experimentation to Realization. The Internet began as a creative experiment, a way for researchers to share data and ideas. Early networks prized openness and collaboration. That design worked beautifully for discovery, but it also revealed weaknesses as more systems connected together. In 1988, a self-replicating program spread through research networks and corporate systems, creating widespread disruption and demonstrating how scale changes consequence. That incident sparked a new awareness. Networks were no longer simply tools. They were critical infrastructure in need of protection. Institutions that had treated computing as a back-office convenience suddenly faced an operational challenge. The community's response moved security from the margins to the mainstream. Chapter 2. Quiet Intrusions in the Age of Reconnaissance. During the 1990s, many digital campaigns took the form of clandestine access and data collection. These operations often focused on gathering technical knowledge, mapping systems, and obtaining information about suppliers and critical services. Such reconnaissance was methodical, understanding how networks were configured, where weaknesses lay, and which systems mattered most. This era was largely invisible to the public, but it built institutional memory. Networks that were probed quietly one year might be targeted differently a decade later. The essential point is this: preparation preceded consequence. Learning the topology of digital systems created strategic options, and those options reshaped how organizations thought about risk. Chapter 3. Political Pressure in Digital Form. By the 2000s, states began to see digital operations as a means of political influence and disruption. In one notable episode, a country experienced coordinated disruptions to government and media websites during a diplomatic dispute. The incident showed that digital events could influence public discourse, economic activity, and national confidence, and it prompted international organizations to take notice. A related instance where digital disruption occurred alongside conventional conflict illustrated how digital and physical domains can interact. The experience led governments to create new defensive institutions and to reframe cybersecurity as a matter of national interest. Chapter 4. Organizing Capabilities and Institutional Change. As the stakes rose, governments and private sector organizations created formal structures to manage digital risks. Dedicated units, national strategies, and collaborative centers grew from ad hoc responses into standing capabilities. At the same time, the private sector, security companies, academic teams, and independent researchers matured the practice of digital defense and incident analysis. This institutionalization was important for two reasons. It professionalized response, and it created standards for cooperation. Public-private collaboration became essential because much of the infrastructure, communications networks, cloud services, supply chains, is commercially operated. Chapter 5. The Day Code showed physical consequence. A turning point in public understanding came when digital processes were shown to affect physical systems. A discovered campaign targeted industrial control systems, altering their operational parameters while masking the changes from monitoring tools. The technical sophistication and precise targeting of that campaign demonstrated an important truth. Changes in software and control logic can cause physical equipment to behave unexpectedly. The incident accelerated global discussion about the interface between software and the physical world, and it underscored why industries that rely on industrial control systems must prioritize secure design and monitoring. Importantly, our telling avoids technical detail and focuses on the lesson. Digital systems can influence physical processes, and that requires greater coordination between engineers, operators, and policymakers. Chapter 6. when disruptions spill beyond intended boundaries. Another major episode in recent history highlighted a new risk. Once a disruptive program is released, its effects can extend beyond intended targets and create broad economic disruption for multiple organizations and countries. The consequences were largely financial and operational. Widespread outages, lost productivity, and expensive recovery efforts. That episode reframed the conversation about responsibility and restraint. Even carefully planned operations can have unanticipated ripple effects. Policymakers and companies now weigh potential collateral impact more explicitly in strategic planning and incident response. Chapter 7: Attribution, Ambiguity, and Global Norms. A core challenge in managing digital incidents is attribution, determining who was behind an event. Technical forensics, intelligence, and international diplomacy converge to establish context and culpability. Attribution matters because it shapes legal responses, sanctions, and deterrence strategies. Because attribution is technically and politically complex, many states operate in a space of intentional ambiguity. At the same time, independent research groups and cross-border collaborations have improved transparency by publishing forensic reports that trace tools, techniques, and infrastructure. This evolving ecosystem helps raise the political cost of harmful operations and nudges norms toward accountability. Chapter 8: The Trust Problem, Supply Chains and Third-Party Risk. Modern systems rely on networks of suppliers, software libraries, firmware vendors, cloud services, and integrators. Attackers who compromise trusted components can reach many organizations at once. Incidents that exploit supply relationships reveal that convenience, automatic updates, and integrated services can become an avenue for large-scale disruption. The lesson is practical. Security is an ecosystem problem. Stronger vetting, secure development practices, and transparency around dependencies are now central to industry efforts to reduce systemic risk. Chapter 9: People and Institutions. Defense beyond technology. Technology matters, but so do people, processes, and culture. Organizations that prepare for incidents by training staff, rehearsing responses, and establishing clear governance recover more quickly. Incident response playbooks, immutable backups, and redundancy are core resilience measures. Public institutions also play a role. National CERTS computer emergency response teams, international information sharing, and cross-sector exercises build shared readiness. The ongoing work of detection, attribution, and recovery is largely human, a combination of technical skill, leadership, and cooperation. Chapter 10: Emerging Tools, AI, Automation, and Responsible Use. New technologies bring both promise and complexity. Artificial intelligence and automation help defenders detect anomalies and speed response. But they also raise questions about unintended effects and the speed of decision-making. To remain responsible, institutions combine automated monitoring with human judgment, transparent rules of engagement, and clear escalation pathways. Policy conversations now focus on ensuring technology augments human oversight rather than replacing it, a stance that balances innovation with caution. Chapter 11: Norms, Law, and International Cooperation. The international community has begun to articulate principles for responsible behavior in the digital domain. Protect critical civilian infrastructure, avoid activities that cause widespread disruption, and cooperate on attribution and response. Progress is incremental. Differing national priorities and capabilities complicate treaty-level agreements, yet there is momentum. Joint statements, multilateral fora, and technical cooperation are shaping a web of norms that aim to reduce harm while preserving legitimate national security and law enforcement needs. Chapter 12: The Path Forward, Resilience, Transparency, and Public Engagement. Looking to the future, 3 priorities stand out. First, resilience. Organizations must design systems that tolerate incidents without cascading failure. Second, transparency and auditing. Independent review and clear reporting reduce ambiguity and build trust. Third, public engagement. Citizens, businesses, and civil society must participate in setting rules for digital conduct. The history that brought us here is a cautionary tale and an opportunity. With careful governance and shared responsibility, societies can harness digital technology while minimizing the risks it creates. The internet was built to connect minds. Our challenge now is to ensure connection coexists with safety and accountability. If this investigation sharpened your view of the digital age, subscribe to NEXION. Tell us below which priority matters most to you: resilience, transparency, or international norms. The conversation shapes policy, and the future depends on it. This was the Covert Origins of Modern Cyber Operations, a NEXION documentary.